Hello everybody, I am Majid Mollaeefar and welcome to my presentation entitled Chatbot Confession, Larger Scale Analysis of Private Data Disclosure in Shared AI Chatbot Conversations. In the context of AI chatbot, you might have seen around a year ago at the beginning of August 2025, some news came up regarding ChatGPT platform with these titles. But what was the issue? When users click share, they were presented with an option to tick a box labeled make this chat discoverable. Beneath that, in a smaller, lighter text, as you can see marked in yellow, there was a warning explaining that chat could then appear in search engine results. Many users had no idea this was happening, although ChatGPT and OpenAI later tried to de-index these links, but archive copies remain. This real world incident is exactly what motivates our study. And let me now explain what we set out to answer our research questions. We define three research questions. The first one is about prevalence. What is the degree of the private data disclosure? The second one is about the severity. To what extent are disclosure high risk from a privacy harm perspective? The last one is about pattern. How do patterns vary across the conversation length and temporal progressions? To address these questions, we made three contributions. First, about the scale, over 100,000 real conversation across three platforms has been analyzed. Second, we propose a hybrid pipeline combining deterministic detection with the LLM-based contextual reasoning validated against human expert annotations at 77.5 accuracy with the substantial inter-rater agreement. Third, we zoom out a little bit on longer conversation and analyze statistical evidence on temporal disclosure pattern, and we found out that they are 2.5 times riskier. Before I walk through how we did this, I want to address the ethical dimension of the work directly. We acknowledge the tension directly in the paper. These conversations were made publicly accessible after explicit user action, but the public backlash and platform subsequent de-indexing effort showed that many users did not fully understand this. Therefore, we took a series of concrete safeguards. First, collection. We do not disclose how we collect and obtain these links. Even public discovery has been addressed. Pseudonymization, all PII replaced with a cryptographic placeholder before any LLM processing. All the data processed on the isolated infrastructure, no data sent to external API. No manual reading, conversation not read or distributed within the team, except 200 conversations for the validation phase. The dataset upon the acceptance of the paper already has been deleted, and we only report aggregated statistics, nor the content published. With that established, let's see the privacy risk assessment framework we built for this study. We established a comprehensive privacy risk framework to systematically assess the privacy risk in the conversation. The framework has three components. The first component is privacy taxonomy, a structured enumeration what count as a private in the chat context with 12 categories and 44 fine-grained PII code. Aligned with the GDPR, NIS, HIPAA, and PCI DSS. The second component maps these categories to Linden framework, a well-established privacy threat framework, so we can connect what was disclosed to the specific harm it could cause. And then the last is risk scoring rubric that quantifies severity along three dimensions: sensitivity, identifiability, and exposure. And these three components allow us to move from a raw conversation to a structured, reproducible privacy risk score. Due to the time limits for this presentation, I skip to explain in depth for each of these components. For interested audience, I refer you to section 3 of our paper for more details. Now let's review our pipeline analysis. A pipeline has three phases. Phase one is data collection. We crawl the public share conversation URL from ChatGPT, Copilot, and Gemini to collect raw conversation. Phase two is the data preparation, which transfer the raw data into analysis-ready input through user content extraction. Also, we did chunking for the long conversation and pseudonymization of PII before any LLM sees the text. And phase three is the LLM-based evaluation. Each prepared snippet is sent to the local hosted model with a structured prompt embedding the full taxonomy, contain the full taxonomy, the threat framework, and a scoring rubric risk assessment output. Or a JSON object which detected the category, risk score, Linden mapping, and reasoning and rationales for the decision of evaluation on each conversation. So now let's see some of our analysis result. Research question one was about prevalence. As you can see in panel A, the overview of privacy issue shows in total 9,623 issues. This corresponds to approximately one privacy issue per 10 conversation, revealing the fact the substantial degree of PII disclosure. Only 15 identified issues remain uncategorized, and the uncategorized subset comprises edge cases resulting from malformed LLM response and parsing failure where the model generated category labels outside of our predefined taxonomy. A research question number two was about severity. As you can see in panel B, 23% of issues are high and or a critical risk. The takeaway from this analysis, these disclosures represent real and actionable threats to privacy, often arising from user unawareness or underestimation of persistence, of indexability, and technical possibility of cross-platform linkability. To address our research question number 3 regarding disclosure pattern, we analyzed them through two complementary lenses, conversation lens and temporal pattern. In terms of conversation lens, for this analysis, in our dataset, we identified 2036 conversations long enough, and among them, 20% contain privacy issue. As you can see in figure A, the comparison is between conversation with and without privacy issue. Conversation with the issue are on average 90% longer, nearly 2 times longer, with a mean of 8.77 chunks versus 4.46 for those without. By looking at the risk level plot, this plot, as you can see, we understand that severity pattern is even more striking. It demonstrates that not all privacy issues are equal. The severity risk is strongly associated with the conversation length. Some of the observation here is critical risk emerge in the longest conversation, high risk conversation are substantially longer, and low risk issue can occur at any length. And the takeaway here is extended conversation appear to create compounding disclosure opportunity as users become more comfortable and share increasingly specific context over the time. But the lens only tells us that long conversation are riskier. It doesn't tell us where in those conversations the disclosure happen. This is a temporal question. For that, we analyze 407 multi-channel conversations containing privacy issue, yielding 1,182 individual findings. Each issue was mapped to its relative position in the conversation, divided into four quartiles. In this plot, the distribution is striking and highly non-uniform. As you can see, Q1 and Q2 each account for 12%, Q3 for 15%, but Q4, the last quarter, accounts for 60% of all disclosures. In conclusion, we presented a comprehensive empirical analysis of private disclosure based on over 100K real-world shared dialogues across three platforms. The analysis leveraged a novel hybrid privacy detection pipeline. Our finding revealed that roughly 8% of shared conversation contain privacy-sensitive information. Extended conversation exhibit 2.5 times higher privacy risk rates compared to the brief one, and with the most severe risk emerging almost exclusively in the lengthy dialogues. Results demonstrate the issue and the risk of private disclosure in AI chatbots conversation are real and systematic and increase with the conversation length. Addressing this risk require a multifaceted approach. AI chatbot platform designer must tackle the persistence vulnerability inherent in the sharing mechanism. System should anticipate and manage the progressive nature of user disclosure over the time. And lastly, a new class of privacy enhancing technique is needed. Mitigating these risks require a coordinated effort among platform developers, policymakers, and researchers. Thank you for your attention.